Okay, so this is basic switch and end device configuration. All end devices and network devices require an operating system. Cisco's operating system is the iOS. It is proprietary to Cisco, meaning it's created by Cisco, and it is for use on Cisco equipment. Now, there are three things that you have to be familiar with within an operating system. The first one is the shell. The shell is the user interface that's going to allow users to request specific tasks from the computer. These requests can be made either through the CLI, command line interface, or the GUI, graphical user interface. Next, you have your kernel. Your kernel communicates between the hardware and the software of a computer and manages how hardware resources are used to meet software requirements. And then you actually have your hardware. So, the hardware is the physical part of a computer, including all the underlying electronics, all the circuitry, all of that stuff, things of that nature. So when we're using the CLI, the user interacts directly with the system in a text-based environment by entering commands. So this is what you're going to learn in these courses going forward. The GUI environment you should already be familiar with. It's what Windows is based on. So think of your desktop where you click on things and you have drop-down menus. That's the GUI. You're going to learn different commands on the keyboard using a command prompt and using a simulation software in order to get in there and to speak to and configure your devices. Now here the CLI requires very little overhead to operate. However, it does require that the user have knowledge of the underlying command structures that control the system. So in this example, you're looking at an example of Linux. Linux is a programming language, and so in order to know what to do, in this example, ls means to list, make a list. And so as you see, it lists certain things. It's listing the desktop, the downloads, lab support files, second drive, things of that nature. In order to get output from your devices in CLI, you need to know the correct command. So again, a graphical user interface, a GUI, allows the user to interact with the system using an environment of graphical icons, menus, and windows. It is more user-friendly, so it requires less knowledge of the underlying command structure that controls the system. Do understand that underneath all this GUI is command structure that allows the GUI to take place. So examples of GUIs are Windows, Mac OS, the Linux KDE, Apple iOS, and Android. GUIs can fail. They can crash or simply not operate as specified. You have to think about these things. You're looking at a graphical picture. This was set up for you, the end user who has very little knowledge of programming language. These menus and these GUIs are actually created by software engineers in command structure. So for these reasons, network devices are typically accessed through a command line interface. Now, the purpose of an operating system. PC operating systems enable a user to do the following. We can use a mouse to make selections and run programs. We can enter text in text-based commands, and we can also view our output on a monitor. Within your CLI-based networking operating system, it enables a technician to do the following. I'm also going to use a keyboard to run my CLI-based network programs. I'm going to use a keyboard to enter text in text-based commands, again using the Linux example here. And I'm going to view output on a monitor, which is the default. Now, in order to get into our devices physically, we need different cables and access methods. So the first access method is a console. So a console is a physical management port used to access a device in order to provide maintenance, such as performing the initial configurations. So in this picture here, you see the cable that is listed above there or shown above there. That is an old school Cisco rollover cable or console cable. It is used to physically connect from your PC, laptop, whatever you happen to be using, into the device itself, be it a router, a switch, access point, whatever. Then you have Secure Shell, SSH. Secure Shell establishes a secure remote command line interface connection to a device through a virtual interface over an internet. This is the recommended method for remotely connecting to a device once you have the device initially configured. Telnet also establishes an insecure remote command line interface to the device over the network. However, user authentication, passwords, and the commands are all sent over the network in plain text. So you never want to use something like Telnet out in a production network. However, in a lab environment, Telnet is perfectly fine to utilize. Always out in production, SSH or another type of secure login method. What you see down here I can't get my cursor over to the other screen here. Oh, hold on, guys. What you see down here are different emulation software packages. This one actually is not two different ones. This is PuTTY. So the last component that we need is a software emulation package. These are open source, they're free, anyone can download them. This one is an example of PuTTY. This is the interface between you and your device. So a terminal emulation program are used to connect to a network device by either a console port or by an SSH or Telnet connection. There are several terminal emulation programs to choose from, such as PuTTY, Teraterm, and Secure RT. In the lab area, we use Teraterm. I myself do prefer Teraterm. So on the left-hand side here, you see an example of PuTTY. And on the other hand is an example of Teraterm. Now, primary command modes, you need to know the modes, you need to know the sequence they come in, you need to know how to get from one to the other. Understand that there are only specific commands that will work under each one. So your very first one is user command mode, user exec mode, I'm sorry. It has limited capabilities, but is useful for basic operation. It allows only a limited number of basic monitoring commands, but does not allow the execution of any commands that might change the configuration of the device. It is identified by the CLI prompt that ends with the symbol that is the greater than symbol. When you are asked to identify a prompt, you start with the device's name and you go all the way to the symbol. So as an example, that entire thing, either switch or router, is the prompt for exec mode, user exec mode. So you might see something like this in an arena where you have a new intern into your network or into your organization, and you want he or she to kind of go around and look at your network and try to get an understanding of how your network is working or running, but you're not going to allow them to do anything. You can have an intern, again, who you might allow to change with certain commands. So within user exec mode, I can identify the user and give them different privilege levels, where a privilege of 0 is going to be no capability to change anything, and the highest would be a privilege of 15, which would be the network admin who has the capability to change everything. So you have that varying space in between 0 and 15, where you can allow certain capabilities to different engineers or interns or admins. Now the next one is privilege exec mode. To execute configuration commands, a network administrator must access privilege exec mode. There are also higher configuration modes like global configuration mode, but global can only be reached from the privilege exec mode. And the privilege exec mode is identified with the pound sign. So again, when you're identifying a prompt, you are looking at from the name of the device all the way up to the symbol. So we're going to talk about configuration modes and sub-configuration modes. So again, we start with user exec mode. This mode allows access to only a limited number of basic monitoring commands. It is often referred to as a view-only mode and identified by the greater than symbol. Next, you have privilege exec mode. This mode allows access to all commands and features. The user can use any monitoring commands and execute configuration and management commands, identified by the pound sign. Next, you have global configuration mode. Global configuration mode is used to access configuration options on the device. Then you have line configuration mode, which is used to configure console, SSH, telnet, or AUX access lines. And then you have interface configuration mode. This is used to configure a switch port or a router's interface. And so you need to understand as we're going along how the different modes change and what prompts represent each mode. Now, to move from one mode to the other. To move from user exec mode to privilege mode, you want to use the enable command. So while you're in user mode, you type in the word enable, you hit enter, and you see it change to privilege exec mode. You want to pay attention to this, okay? You want to start watching these configuration modes and watching the prompts change as we go through and we configure. This is what you need to be learning. So again, user exec. I type enable, I press enter, and I am now in privilege. Now, to go from privilege exec mode into global configuration mode, which again, global affects the entire device. Okay, I want to type in config terminal. So here, up here at the switch prompt here, I would type in config T or terminal and press enter. And that gets me to global. Now, the entire prompt for global is as such. Okay? To return to privilege, I type in the word exit, and exit will bring me back one mode. Now, line configuration mode, so these are these sub-configuration modes. Line is your first one that we're learning about. So line configuration mode. When you want to go into any one of those lines, and again, you have line con 0, you have line AUX, you have line VTY. Any one of those, you get there with the line configuration mode. So first thing you do from global is you type in the line that you want to get into, as you see here. In this example, I'm going into line console 0. Now, I hit enter. Now pay attention to the line prompt. So that whole thing is the prompt for line. Again, if I want to return to global, I hit exit, or excuse me, I type exit, and that brings me again back one mode. So when the CLI is used, the mode is identified by the command line prompt. That is unique to that mode. By default, every prompt is going to begin with the device's name. Okay? So again, we have user, we have privilege, we have global, and we have line. These are all your different prompts. So sub-configuration modes. To move out of any sub-configuration mode to get back to global, you're going to use the word exit. To return to privilege. So exit again is going to bring you back one mode. To return to privilege, I can either type in the word end, or I can do a key combination of Control Z. That's going to bring me all the way back to privilege. To move directly from one sub-configuration mode to another, I type in the desired sub-configuration mode. So in this example, I'm going to go from line mode, and I know this because it is config line, into interface mode. So this is the next sub-prompt that we're going to learn about, or sub-configuration, is interface. Okay? Once I type in the appropriate interface that I'm looking for, in this example, interface Fast Ethernet 01, and I hit enter, now look at interface prompt. Okay, so I cannot stress how important it is for you to know the different prompts and how to get back and forth between them. And also understand that only certain commands are going to work under certain prompts. Now, do understand that once you're in line mode, you can configure any one of those lines. Line console 0, line AUX, line VTY. You do not have to keep going all the way back out to privilege, get to global, and then go back into line. Likewise with interface. Once you're in these sub-configuration modes, you can just go in there and configure as many lines as you need. Once you get into interface mode, you can go in there and just configure as many interfaces you need. You don't have to keep going all the way back out and coming all the way back in. Now, you do have to understand the basic command structure. So a Cisco iOS device supports many commands. Each iOS command has a specific format or syntax and can only be executed in the appropriate mode. Within the iOS, you have keywords and you have arguments. Now, a keyword, this is a specific parameter defined in the operating system. Okay, so that means that is something that is embedded in the Cisco iOS. Okay, meaning it's part of the operating system. Okay, so this is again a specific parameter. In this example, IP protocol. So we're going to break down this little image in 1 second. An argument is not predefined. An argument is a value or a variable that is defined by us, the user. Okay, so it is not embedded in the Cisco iOS. So after I enter each complete command, including any keywords and arguments, I want to press the Enter key to submit the command to the command interpreter. And we'll find out what happens as we go along if you have errors. So now the way you understand this graphic, first thing you need to understand is the prompt. So in both of these examples, the top one being your keyword, the bottom one being your argument. Switch with the greater than is our user prompt. I'm sorry about that. Next, we have your command. Your command is something you are asking your device to do. In this example above, I am saying show. So the show command are asking your device for information. Okay? So the first one is saying, show me anything you know about your IP protocols that you have on yourself right now. The second one is saying, ping something. So ping is the command. So I can use show commands asking my device for information to output, or I could also be asking my device to test something. So ping is a testing. Show is outputting information. Each of these, okay, each of these fall under user exec. Now lastly, above, IP protocols is a key word because it is embedded in the iOS. And down the bottom, this one is an argument. Because we are asking it to ping someone, to test someone. Now, a command might require one or more arguments. To determine the keywords and arguments required for a command, refer to the command syntax. Syntax is simply the language that your devices understand, your programming language. Now, boldface text is going to indicate commands and keywords that are entered as shown. Italic text indicates an argument for which the user provides the value. So, boldface indicates commands and keywords that you enter literally as shown. Italics indicates arguments for which you supply values. Square brackets indicate an optional element. Braces indicate a required element, which is either going to be a keyword or an argument. Excuse me, and then braces and vertical lines within square brackets will indicate a required choice within an optional element. Spaces are used to clearly delineate parts of the command. So the syntax for using the description command is description and then a string of words, which is whatever you want to identify. So the argument is string. So a string value which is provided by the user. So the description command is typically used to identify the purpose of an interface. So as an example, entering the command description, which again, description is the command. Okay, followed by your string of characters, which simply says connect to the main headquarters office switch. So when you are doing your descriptions on your interfaces, you want to make them something that means something. When you look at the show run command from your devices sitting at your desk in your office, you should be able to look at this interface and know exactly where it is attached to. So following examples demonstrate conventions used to document and use iOS commands. So here, my ping is my command. IP address is my user-defined argument. It will be the destination device that you're trying to test. So as an example, I want to ping whoever or whichever device has the IP address 10.10.10.5. Now traceroute maps through the network how your information travels. So the command here again is traceroute, and the user-defined argument is the IP address of the destination device. Again, so I want to trace something from source to destination, so the generating device to the ending device, and I want to see how it goes through my system or through my network. Now your iOS has two forms of help. They have context-sensitive help and they have command syntax help. Okay, while both of these are very helpful, okay, understand that I don't want to see during an exam you constantly using the question mark. That indicates to me that you really don't know what you're doing. Now, is it helpful and does every programming language have help features? Of course they do. So when you're just starting out, definitely use that question mark. Okay, but when you're going through, you need to really know what you're doing within command line structure. So context-sensitive help enables you to quickly find answers to these questions. Which commands are available in each command mode? Which commands start with specific characters or a group of characters? Which arguments and keywords are available to particular commands? So if I type the word ping and space, it's going to bring up everything that I could do. So I could ping a word if I have my system set up to do so. I could ping an IP address. So when you see just IP alone, it means IP4. Make that a little better for you. It's kind of sloppy. Okay, so whenever you see IP alone, it stands for version 4. If you want to utilize IP6, you actually have to type in V6. Now, command syntax check verifies that a valid command was entered by the user. If the interpreter cannot understand the command being entered, it will provide feedback describing what is wrong with the command. Not only will it tell you that you have an error, it will tell you exactly where you went wrong with your syntax. So when you see this little caret symbol, okay, this tells you exactly where you went wrong. So it's invalid input because your device doesn't understand the syntax you're trying to use. So it's invalid, and it is invalid right here. So an example here that might describe or might explain this particular circumstance is we have in these labs 3 different types of models of switches, 3 different types of models of routers. Each one has certain interfaces in them, or on them, excuse me. Most likely when you type in an interface, okay, and you're here, it could be one of 2 things. Okay, you could be in the wrong mode. Here I'm in privilege mode. Do I need to be in global? Or it could mean that my device doesn't have this interface. If your device does not have an interface, you want to issue this command, and please get used to using this command. Okay, so to find the interfaces, on your device, you are going to issue the command show IP INT brief. Now I'm truncating things here, meaning I'm shortening the commands. When you first start out, it's very common for students to type each individual word out, which is perfectly fine to get used to the wording and what these actually mean. But this one actually means the word show. This one is saying IP protocols or internet protocol. INT instead of typing out interface. And then brief means give me a summary of what my device has on it right now. So you will get used to truncating your commands the more you get into, command line structure in your interfaces. And it is, I do not have a cut sheet, I don't have anything to hand out to you, a little cheat sheet. It's you just working through it yourself and figuring out the shortest path to use, that will execute to use these truncations. So the iOS command line provides hotkeys and shortkeys that make configuring, monitoring, and troubleshooting easier. Commands and keywords can be shortened to the minimum number of characters that identify a unique selection. For an example, the configure command can be shortened to config because configure is the only command that begins with config. So it is just going to be you playing around with shortening the command to see which one is going to be useful for truncation. You also want to get used to your hotkeys and shortcuts. Your tab key is going to complete a partial command name. So if in the correct command prompt you type in CONF and hit your tab key, it will complete it, and you will see the word configure. Okay? Do understand when you're using your tab key, you need to be in the correct mode in order to have it happen. You also need to, let's say that you type in something, you type in CO, and you hit tab, and you get nothing, it just returns you with CO. This means that there's too many options available and your device does not know which one you want it to do. So when you're playing around with this, next thing I would do is CON and hit tab key and see if that works. So you kind of have to step your way through letter by letter. And where it does configure or complete is the shortest version of that command. Now your backspace erases the character to the left of the cursor. There is no delete option when you're in your devices. So you have to use the backspace to get rid of characters. Your left arrow or Control B moves the cursor one character to the left. Your right arrow or Control F moves the cursor one character to the right. Your up arrow or Control P recalls the commands in the history buffer, beginning with the most recent command. So get used to using your up arrow, down arrow, left, right arrows. They will help you. When a command output produces more text than can be displayed in a terminal window, the iOS will display a more prompt. I saw one or two of you looking at this baffled when we did our lab. Okay, when you see more, that is your device saying, hey, I have more to tell you. I'm going to say has more to list. So if I hit the enter, it simply brings up the next line. If I hit the space bar, it brings up the next screen. If I hit any other key, it ends the display screen and returns you to privileged exec mode. If I hit Control C, when I'm in any configuration, it ends the configuration and returns to privileged exec mode. Control Z brings you all the way back out to privileged exec mode. Control Shift 6. This is for when you're into a ping or into a trace route. And it keeps going and keeps going and keeps going. On your devices, your switches, your routers, you are going to do Control Shift 6 all at the same time. Okay, all three of those keys, and that will abort it. On your PCs, it's going to be Control C. Okay, so in order to abort those, that's how you would get out. So the first configuration command on any device should be to give it a unique name. So when you purchase a device from a manufacturer, unless you purchased it pre-configured by them, they have the default name of either switch or router. So as you see here, I have 3 switches in this dynamic. If they were all named switch, I, the administrator, sitting in my fancy little office and looking at my show running command, I would have no idea which one was where. So you want to name your devices and you want to name them appropriately. So you want to start with a letter, contain no spaces, end with a letter or digit, use only letters, digits, and dashes, and be less than 64 characters in length. So when I do this, I know now that that is switch floor 3, switch floor 2, switch floor 1. Okay? So again, no spaces. I can do this. I can do this. I can do this. I cannot do this. Oops, let me not confuse you. No spaces in names. Okay? No spaces in names. To return the switch to the default prompt, I would simply put the no in front of the host name command, and that will bring me all the way back out to the default. Now, the use of weak or easily guessed passwords is a security concern. All networking devices should limit administrative access by securing privilege exec, user exec, and remote telnet access. So this is your first introduction to security on your devices. In addition, all passwords should be encrypted and legal notification should be provided on your device, warning someone that they should not be there if they don't belong there. So password guidelines. Use passwords that are more than 8 characters in length. Use a combination of upper and lower letters, numbers, special characters, and/or numeric sequences. Avoid using the same password for all devices. Do not use common words because they are easily guessed. However, all that just stated, in your labs, on your finals, you will use either Cisco or class unless otherwise specified on the lab. These passwords we know are considered weak and easily guessable and should be avoided in production environments. But that is what you're going to use in your lab environment and in your final environment. Now, to configure your passwords, there are 3 that we're going to start out with. There's 2 here. So first, enter LineCon configuration mode. I do this by typing in LineCon 0. First, let's not forget our modal system. I start here. Which is user exec. I type in enable. I now get to privilege. I type in config T. And now I'm in global. Oh, it's right here. I didn't even see this. So now I'm in global. Okay, this is global. From global, I identify the line I want to get into. In this example, line con 0. Now, con 0 is your console line. This is how you physically get into that device. Password is my command. Cisco is my argument. Okay? So password is my command. Cisco is my argument. It is an argument because it's not embedded in the iOS. You could give this a password of whatever you would choose. So therefore, it's not going to be embedded in the iOS. The login word is very important. Okay, you need to have login. So first enter the LineCon configuration mode using the LineCon 0 in global configuration. Next, specify the user exec mode password using the password command. Finally, enable user exec access using the login command. If you misconfigure in the login command, your device will not prompt you for the password and you will not get in. Now, securing privilege exec. So when you think about this, your privilege exec mode, what this next password has to do with is you have to think about, what do I have to type in order to get to privilege? Because privilege is where I can change things. So what is that word? That word is enable. So what this command says is when someone types in that word enable in order to try to get to global, they better know this secret password. The word secret is encryption. Class is your argument. Okay. So now you've seen your first 2, your LineCon 0 and protecting your enable command, because enable gets you into global. Now, securing your VTY lines. So VTY stands for, in a short version, virtual tele lines. Okay, so you first enter the VTY that you want to get into. Now, understand, in this example, we're on a switch. Your switch has available 0 to 15, which gives you 16 virtual lines. Your routers have 0 to 4, which give you 5 virtual lines. Okay, but there can be more depending on the models. So after you get into line VTY, and in this example, I am going to put the same password on all 16 of these lines. You could separate out each VTY line, but that is beyond the scope of this course. Again, password is my command. Cisco is my argument. Login is needed. Login prompts me for the password. If I were to remotely log in and I forgot either the password or the login, I will not be able to remotely get into my device. Now, again, VTY lines enable remote access using Telnet or SSH into the device. Many Cisco switches will support up to 16. So what will tend to happen is, when you see it like this, line VTY, and you type in as a human 0 to 15, you may see when you do a show run on your devices that it will actually populate as such. Okay, so no tremendous rocket science as to why it does this, but do understand, don't get confused. It still means 0 to 15. They just put it on 2 different lines. Now, the startup config and running config. These display most passwords in plain text. So what we don't want is someone standing behind us while we're on our devices and we happen to do a show run and we're under our line configurations and you can see every password that we've put on because it's in plain text. We don't want that. Okay, that is a security breach. So we go into config T and we say the command service password encryption. So what service password encryption does is it encrypts every current password in plain text that you have right now, and any future. Now you have to be careful with this. If you, for some reason, you want to take off service password encryption, you can do that with the no command. In front of the actual service password encryption command. However, it does not unencrypt what you've already done. Okay, so just be aware of that. Now, when you're looking at this output after you put this command on, and I thoroughly thoroughly encourage you to always do show runs while you're learning this stuff. Type in a command, do a show run, see what happens, see where it lies in the configuration, get used to understanding your devices. So what you see here is this is whatever your password was encrypted. I will tell you what this is, even though you are not held to know what it is. It is a hashing method. Which you do not need to know about, but that's what that 7 is. Hashing simply falls under encryption, and it's just the means on how these encrypted outputs are created. Now, your banner message is important. It is to warn unauthorized personnel from attempting to access your device. To create a banner of the day on a network device, you're going to use the banner NOTD, which means message of the day. Okay. The only parameter, or the necessary parameter, I should say, is you have to use the same delimiting characters. And your delimiting characters are your meta characters. Okay, and those are the symbols above the numbers on your keyboard. You have to start and end with the same one. So as you see in this example, my command is banner MOTD. My argument is here. Okay? Again, it's an argument because it's not embedded in iOS, because I could make my banner say whatever I want it to say. And it has to start and end with the same delimiting character. Now, the interesting thing about this is when you do a show run, your banner is displayed directly above your line configuration, almost to the end of your show run. So if you type in exit, and this is how you're going to see it when you do this, you type in exit twice. It'll bring you all the way back out of your device. When you go all the way back into your device, it should be the very first thing you see. Okay? It should be your warning. So let me write that. Now, when you do that, so this is the very first thing you see, then it's asking you user access verification. This very first password that it's asking you for is your console. So whatever password you put on your line console 0, or whatever console line you're using, That's the password it's asking you for here. Now, there are two file systems or system files that store the device configuration. Your startup config is the saved configuration file that is stored in NVRAM. It contains all the commands that will be used by the device upon startup or reboot. Flash NVRAM does not lose its contents when the device is powered off. So your startup configuration is the one that is saved back to your device after you make changes. That is that copy, run, start that you do. Now your running configuration, this is stored in random access memory. So this is live time, it's what you're doing right now. It reflects the current configuration. Random access memory is not saved. So if you lose power, if something happens, anything you've done, unless you have saved it, is gone. Modifying a running configuration affects the operation of a Cisco device immediately. RAM is volatile memory. It loses all of its content when the device is powered off or restarted. So NVRAM non-volatile, RAM volatile. To save changes made to the running configuration to the startup configuration, it is copy running config startup config, which translation means copy what I'm doing right now to my startup file. Okay, so that when I reboot my machine, everything I've done will be saved. If changes made to the running config do not have the desired effect and the running config has not been saved, you can restore the device to its previous configuration. So one of two ways I can do this. I can do it the very laborious way and remove each command that I individually put in, or I can just simply reload the device. So the reload is kind of like you rebooting your machine. So you reload the command in the privileged exec mode. This will cause the device to briefly go offline, leading to network downtime. Now, what you see here, it's going to prompt you, are you sure that you want to reload this machine? Okay, again, when something is in the brackets, it is a default answer, and if you want that default answer, you just press enter. If the undesired changes were saved to the startup config, it may be necessary to clear all of the configurations. So if I need to clear all of the configurations, I am going to use erase startup config, which erases everything on that device and brings me back to my factory default. Okay? After I say erase startup config, I need to also issue the reload command. And if I am prompted to save, I want to make sure I say no. Now, capturing a configuration to a text file is something I'm going to go over once we get more into our lab scenarios. So I'm going to skip it here. Likewise here. Statically assigning our addresses. Okay, I gave you this handout at the end of your first lab, basic switch configuration. So the use of IP addresses is the primary meaning of enabling devices to locate one another and establish end-to-end communication on the internet. The structure of an IP address is called dotted decimal notation, as you see here. It is represented by 4 decimal numbers between 0 and 255, separated by a period. An IP4 subnet mask is a 32-bit value that differentiates the network portion of the address from the host portion. and we will go through that the further along we go in our studies, as well as it being coupled with the subnet mask, which determines to which subnet the device is a member. And then lastly, you need the default gateway, which is the IP address of the router's interface that is directly connected. So we will go through that again as we go along. Excuse me. But when you're statically assigning an end device, depending on the end device, you need either two of these parameters or all three. Now again, this is how you do it in IPv6. So IPv6 is 128 bits in length, written as a string of hexadecimal. Excuse me. So every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values. There are groups of 4 hexadecimal digits that are separated by a colon. IPv6, however, is not case sensitive. So what that means is this means the same as this, means the same as this, means the same as this. Likewise, all the way through, not case sensitive. It is the most recent version of IP, and it is replacing the more common IP version 4. Now, we're going to talk more about these as we go along, especially the cabling when we get to Chapter 4. Network communication depends on end user device interfaces, network device interfaces, and the cables that connect them. So types of network media are going to include twisted pair copper cable, fiber optic cable, coaxial cables, or wireless. Different types of network media have different features and benefits. Some of the differences between them are the distance that the media can successfully carry a signal, the environment in which the media is to be installed, the amount of data and the speed at which it must be transmitted, and the cost of the media and its installation. Again, manual configuration. These are the steps in Windows 10 on how you go through and do this. The document I gave you in class on the lab is the newer version, or the shortcut in command line using your search bar how to get directly to where you need to configure your devices. Automatic IP address configuration for end devices. So normally when you go into your machines, your devices, your PCs, they will be on obtain an IP address automatically. This is because there is a protocol called DHCP, Dynamic Host Configuration Protocol, which enables automatic IP for addressing for every end device that is DHCP enabled. This is something you will learn more about in Cisco 2. In order to give it and take it from this parameter, you need to change it to use the following IP address. That is how you statically assign. So you need to click on this radio button for that static assignment. Once you do that, you populate your IP address, your subnet mask, your default gateway, and then likewise in IP6, oh, I'm sorry, this is your DNS server if you want a preferred DNS server. Also, IPv6 uses DHCP version 6 and SLAAC, which is stateless address auto configuration, which we'll talk more about when we get to that chapter. So you have to do IP4 and IP6 if your lab calls for it. Now, in your switching environment, you have 2 different types of switches. You have layer 2 switches and you have layer 3 switches. For the most part, a layer 2 switch will look like this. And a layer 3 switch looks more like a block diagram like this with a little thing in the middle of it. Something like that. So layer 2 and layer 3. A layer 2 by default is unmanaged. Meaning, it is just working as a one-to-many connection device. A layer 3 switch is more of a managed switch. You have more capabilities in your layer 3 switch than you do in your layer 2 switch, but that is beyond the scope of this course. So I am just going to tell you that we teach you now how to put an IP address on your interface VLAN 1, which is how we manage our switch. So the only reason at this juncture to put an IP address on interface VLAN 1 is for remote login. Okay, so at this juncture, that's really all you need to know about it. We also do, which is not in this picture here, put in an IP default gateway. Which is the router's interface, and we'll talk about that more as we go along. I'm just going to pop one in here as an example. Okay, so we'll talk about that the further along we go in our studies. So that is all about your switch and basic configuration modes, and I will see you next class.